Let me turn on the switch. And you can see this is now doing its thing as intended. Hey there, this is Seth Schiefer from Team Just Cause Robotics, and in today's video I'm going to show how you can prepare your brand new Switch PD board for use in your robot. For the sake of demonstration, I'm using these yellow XT30U connectors, which you can get pretty much anywhere, but I also sell black ones on my web store. These yellow ones just show up a bit better on camera, but they are compatible perfectly with the black ones that I sell as well. So if you happen to already have some yellow ones, you can mix and match with the ones that I sell, or just stick with those, whatever's your preference. Now, the board will come to you looking like this. Basically, it will just have the switch installed, and that's it. You have the press nut on this side and the screw on this side, and they will all come just like this. You have the choice of putting your connectors on the, what I would call the top side, or on the bottom side. The only thing that you have to keep in mind is you need to make sure that the rounded side points towards the top of the board or away from the screw like you see indicated on the silk screen here. Now, I'm going to, for the sake of example, show how to solder onto this side since it's a little bit simpler. First, however, what I recommend you doing right after you buy this board is to solder a better connection for the press insert nut, because right now it's just kind of shoved in here. There isn't necessarily a great electrical connection. I recommend doing this on my Switch boards, my Switch PD boards, and my all-in-one PD boards. So I'm just going to show quickly how to do that. Got some solder here, going to turn on my fume extractor. And I've got my soldering iron set basically as hot as it'll go. What I'm going to do here is heat up the pad and the nut a little bit, and then get some solder on there. Touch it to the nut and the pad. Careful not to accidentally fill in the hole where the C30 needs to go right now. I'm just going to get the whole board nice and hot, and we should be able to feed solder in around it without risking it bridging to anywhere we don't want it, like so. You should see the solder flowing to cover both the board and the nut. If it's not touching both, it's not a good connection. Now I'm just going to wait a little bit for this to cool off, because it's rather hot now. So this is what a good solder joint should look like there on the press nut. Wow, it's still pretty hot. You can see the solder joins around the entire perimeter of the nut to the board. Alright, now for soldering on the connectors. Now, the easiest way to do this, depending on which orientation you want to do it, you just got to make sure, once again, that the rounded side of the connector is pointing to the top edge of the board, as indicated here with the silk screening. So I'm just going to line all of the connectors up. I like to put the male connector on speed controllers and the female connector is always on the battery. So on the board you get the opposite, where you've got the male connector here and females here. Now what we can do is simply flip the whole thing upside down. Center it in the shot a little better here. And now all those connectors are going to stay in place for us as we solder. I like to turn my soldering iron down to about 280 C, because that way I can avoid melting the connectors. And you don't want to apply heat for too long here. I'm going to turn on my fume extractor again. I'll start with the battery connection. First I'm going to wet the tip of the iron, keep the tip in place, and then just feed solder around until I see the joint forming that connects the board to the leg of the connector. And then I'm going to repeat with all of these. You don't have to move the tip of the iron around really at all. Just get everything hot enough that you can feed solder in and it melts in contact with everything. If you're not getting good heat conduction, it's because the solder wasn't properly, or the soldering iron tip wasn't properly tinged with solder. Just cover up all that gold or brass with solder so you know you've got a nice solid connection there. That's all there is to it. You can see this connector's a little crooked, so I'm going to fix that one real quick. Perfect. Alrighty, now I'm going to show, for the sake of example, plugging in some speed controllers. So first things first, always double check that the battery connector is the right way up when you've first done this. Curved side towards the top, flat side towards the bottom where it says BAT, or it'll have plus symbols along the bottom for yours. Ground, GND, should be the round side on the top. And that's where the black wire for your speed controller goes. Flat side has the red wire for speed controllers. So I'm going to start out with the battery. If something goes wrong here, that is a bad sign. So I'm just going to quickly turn the switch on, and you shouldn't see any sparks or anything. If you do, that means that your battery is plugged in, and there's a soldered bridge here, and that means that there's a short, and your battery is going to short through the board into itself because of your solder joint being bad. To fix that, you just break a solder bridge here. If you close the switch and then you see that there's a short, then it's because one of these three connections is probably bridged. Now, I don't have any solder bridges, so I'm just gonna loosen the switch screw a bit, plug in 1, 2, 3 speed controllers, and now ta-da! They all light up, and they're all getting power. Now for a more realistic test as to how this would be in a bot, I've got this big servo tester that is a stand-in for a standard RC receiver. It has the same kind of like 3-pin plugs here. I've got this speed controller that has a BEC built in, which is the type you would want to use, well, not this exact one, but you would want a speed controller with a BEC built in to be used with the Switch PD board or have an external BEC by some other means. So I'm just going to connect that guy, and that's going to make it so that when it's powered, it powers the servo tester or your receiver in your case, and this will light up so it's clear to see on video that this is working as intended. And then plug in the battery. Nothing happens because the switch is not activated yet. And then we turn on the switch, and you can see this is now doing its thing as intended. So if you had a receiver hooked up to this, it would now be powered, and all your separate speed controllers you would connect to this, and then they would run their motors as intended. Just like that.